So here we go. I'm gonna do some random checks. I can't do it all, so I may not even do the decimal percent every single time. I'll just do the fraction. Okay. But let's go to page 8 here, and when you have your deck of cards, you should have this on your study sheet. Is it perfect? No. I think you probably can do better than me on this one, but I think this does a pretty good job at letting you know, okay, what's what, okay? I've seen students cram this into small spaces, so 3 by 2, 3 inches by 3. So what is this? 1, 2, 3, 2, this small. So it can be done, right? It can be done. It can be squeezed into a small box like that, so it shouldn't take up too much space on your study sheet. All right. A, state the probability of drawing a 5. So randomly drawing a 5, okay? Let me just tell you, like sometimes they try to throw in words to I don't think they're trying to confuse you. They're just trying to be accurate. It has to be random. If you peek in, or like if you look at somebody's hand, like if I'm holding all 52 cards and you're looking, this is out of the window, right? Like you cannot use this. This is only if it's random, then we kind of use this thinking, okay? So drawing a 5, we've got 4 of them, right? Out of 52 cards. This is your total, and it's 4 5s. I will write that actually. 4 5s. Right? There's 1 for clubs, 1 for spades, 1 for hearts, 1 for diamonds. So there's 4 of them. So this is what we're after. As a decimal, that would get you 0.0769 if you do 4 decimals. If you do 2 decimals, it'll be 0.08. If you do 3 decimal, it'll be 0.077, right? But if you do 4, that's what you get. Multiplying this by 100 gives you 7.69%. So they would all be acceptable. If I don't ask you for all 3 formats, please just leave it like that. Just leave it as a fraction, because if you make a mistake, even if it's tiny, even if it's just rounding, you don't get the full marks there. So just don't do it unless we ask for it, okay? Right now it's good practice, so just go ahead and practice it. State the probability of drawing a face card. There are 12 faces out of 52. That gives you 0.2308, which is 23.08%. Okay? Why is he doing that weird thing with 4 decimals and then, because it's okay to do more than 2 decimals, and then you can see how that turns into 23.08, right? You can see it. But 20.23 would have been acceptable. Probability of drawing a numbered card, not a face card, nor aces. Okay? So we got 52 minus 12 minus 4, because there are 4 aces. You're left with 36. So this would be 36 out of 52. If you want 40 out of 52, that would technically be a non-face card, 40, right? 36, and so that amounts to 0.6923 or 69.23%. All equally, but we like the fractions if at all possible. Working with them reduces the rounding, okay? We don't have to round if we keep it as a fraction. Drawing a blackjack. How many blackjacks are there? 2, right? There are 4 jacks, 2 are black, 2 are red. So we've got 2 out of 52, okay? 4 jacks, right? 2 black, 2 red, if you want to put this in your notes, right? That's why we come up with the 2 over 52. That would be 0.0385 or 3.85%. So it gets smaller. The more specific you get, guys, the less of a chance of you drawing that card. Right? If you just said reds, you've got 26. If you say clubs, that's just 1 suit. And if you go 4 of clubs, it's even less, right? So the more specific you get, the lower your chances. Next, State the probability of drawing a face of clubs. Face of clubs. So what's that? So you've got 12 faces. You've got 3 clubs, 3 spades, 3 hearts, and 3 diamonds, right? 6 are black and 6 are red. So face of clubs, you're really just specific to this one up here. This is all you want, right? So we've got 3 out of 52. And that would be 0.0577. That's 5.77%. Okay. State P, ace of diamonds. I need you to know what this means. It's probability of drawing an ace of diamonds. So we obviously know it's a standard deck of cards, so we've got 52. Maybe I'll come up with different decks that aren't 52, just to kind of, I'll be like, hey, someone is playing with cards, they removed all the faces, right? So now you're down to 40. Now you're playing with that one, or you're drawing from the 40, so you're not always thinking 52, but most of the time it's going to be a standard deck. Ace of diamonds, I have to think here. Ace. Diamonds is a specific suit, and diamonds, there's only one of them, right? So just one ace of diamonds. And so that is going to be a small number. That is 0.0192, which is 1.92%. Remember, there are 4 aces. 2 are black, 2 are red. But ace of diamonds is specific to diamonds. Right? Let me do the cheat again, right? Diamonds is right here. There's only one ace of diamonds. So there we go. What's this one? State P8. This is supposed to have a bar on top. Okay, I hope that, yeah, it didn't work out very well there. That means P of not drawing an 8, drawing an 8. That's what that is saying. That's the translation of that statement. So that would be, if it's not, I would like you to think of this 52 cards, and we have 4 cards that are 8s. Okay, 4 of them are 8s. So we take that away and we still have 52. So we're left with 48 out of 52. I'm going to highlight this one because these are important ones. So not 8. So we take the away, like just basically think of not means like take it away, right? I don't want that. So I take my total, I take away the 4, and I'm left with 48 over 52. This amounts to 0.9231, which is 92.31%. So there you have it, deck of cards. Someone asked me about page 11. Yeah, I'm gonna do 11 as well, just random. Okay, so let's go to 11. Okay, Georgina bought a bag of bulk candies. She counted them and found that 15 were red, 10 green, 12 purple, 13 orange. This is a hint for you're gonna have to come up with a total, right? A, calculate the probability of a randomly chosen candy from the bag being red. Express this as a fraction, decimal, percentage, and in words. So first of all, let's figure out our total. Total would be 15 plus 10 plus 12 plus 13. 25 and 25, right? 50? 50 candies. So that's important. Right? Everything is going to revolve around that one. So A, probability of a red candy. So we're going to go P red like this. Honestly, this is not a requirement. You should know what that means, but it's not a requirement. We've got 50 candies, and out of this 50, 15 are red. Let's try to reduce this fraction, because these ones are fairly simple to reduce. Both are divisible by 5. So I'm going to divide both of them by 5. So 15 divided by 5 is 3. 10 divided by 5 is 10. And actually you cannot reduce it any further, so that would be reduced. I'll just show you how to do it on your calculator. You know it, and for most of your calculator will have this feature. So if you press 15, you gotta, if you have this button right here where my pencil is hovering over, it's like A, B/C. It's like a fraction, to enter a fraction. So if I go press 15 and then press that button followed by 50 and then hit equals, it will reduce it for you. It's like 3/10. And that's why I don't give marks for it, because I know students, eventually you find out, maybe you already knew this, and the province doesn't give you marks for it either. So if it says reduce ever, just use your calculator if that is something I asked for. Some of you might not have that feature, and if you want me to help you find it, I can do so. Anyway, so we've got this. Decimals will be 0.3. As a percentage, will be 30%. And in words, you pick which fraction do you like more, 15 out of 50 or 3 out of 10. It's totally up to you if you're supposed to do this in words. You decide. Okay, B, what's the probability of randomly choosing a candy that is green or purple? So I go P of G or P. All you need to do there is add them up. 10 green, 12 purple. You're still out of 52. That's 22 out of 52. We can reduce that. I think this is a good skill because you might actually need it for post-secondary. I'm not sure what you're going to end up taking. So when they're both even, I keep slicing in half until I can't anymore. Yeah. Oh, sorry. Is it Friday today, or because that's usually when I start making mistakes, is Monday or Friday. Thank you for that. If they're both even, keep slicing them in half until you can't anymore, and then see what else you need to do. So half of 22 is 11. Half of 50 is 25. You're actually done there. You can't go any further because 11 is a prime number. Some of you are thinking Optimus Prime right about now. 11, so this is a decimal. This would be 0.44, which is 44%. Okay. C. C is where I want you to pay attention. Okay. This comes up all the time. If the distribution of colors in a bag of 1,000 candies is the same, what is this word here? Distribution. It's basically if the spread is the same, if it stays about the same as up here, if we would kind of see the same pattern, what would it be in 1,000 candies? Okay, so this is a prediction. You take the probability of the small, okay, and I multiply it by large scale. I know I probably gave you something else in the original formula, but it's okay to change it up because I just make that one up, right? So how many would be red? Probability of red, we already know, is 15 out of 50 or 3 out of 10. It doesn't matter. And we multiply that by 1,000 candies. So you want to see, in 50, we've got 15. What about in 1,000, right? You multiply that. That gives you 300, correct? Yeah. 300 red candies expected. We're making a prediction, right? So this is your final answer there. I think I'm just going to do the bottom of 11. And if you want me to do another one, I can do so. Okay. Consider the letters in the word probability. If the letters making up this word were to be placed in a bag, say the probability of drawing an eye. Okay. So first of all, total is, count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we're talking about 11 letters. And how many eyes are there? 2, right? 2 eyes. So probability of an I is going to be 2 out of 11. Done. Okay? State the probability of drawing a vowel. So one of these. So we've got 4, right? So O, A, I, and I. So 4 vowels. So that would be probability of V is 4 out of 11. That's it. Later on, we're going to talk about what happens when, if I were to go around with a bag of Smarties or candies, I walk around the room and I ask you to grab one, and you grab a red one, and you eat it. Now there's fewer in the bag, right? How does that change our probability to grab a red one when I move down the class, right? It's going to change. That's coming down the road, okay? Okay, I'm going to skip 12. Is there any... I think the rest, honestly, I will just leave that up to you. The key is posted. 15, it's a deck of cards practice chart. If you want to figure out the probabilities of drawing a black card, diamond, face card, 6 of spades on 15, I don't know if I posted the key yet. I don't think so. I will post it. So anything up to 15 is just basic intro to probability. Okay, that's what that is. So I'm going to go to the front. Let's do that. I'm going to go to the front and just say pages 1 to 15 is probability. And then we're going to fill this in. Then later on it's going to be odds, right? And so different topics. That way when you look at it, you know where to go and find. Shall I say deck of cards? Page 4. This is just a little side note, right? Deck of cards is on page 4 if you ever need to go get it. You can Google it, deck of cards, images, and then you'll see it, right? All right. We're going to go odds now.